Hello there, this is Daniel and welcome to our 8th SAT English video. Sorry for not having posting a long time. I had a little bit of trouble with school and break, but now I'm back. Today we're going to be going over another 5 questions, this time on a new section, a new new section of a book written in the SAT English test. So today we're going to go through these 5 questions here. And yeah, let's go. So, first of all, obviously, you want to read through this entire passage, which would be really good. The chemical formula of deoxyribonucleic acid, DNA, is now well established. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. To each sugar is attached a nitrogenous base, which can be of 4 different types. 2 of the possible bases, adenine and guanine, are purines, and the other 2, thymine and cytosine, are pyrimidines. So far as is known, the sequence of bases along the chain is irregular. The monomer unit, consisting of phosphate, sugar, and base, is known as a nucleotide. The first feature of our structure, which is of biological interest, is that it consists of not one chain, but of 2. These 2 chains are both coiled around a common fiber axis. It has often been assumed that since there is only one chain in the chemical formula, there will only be one in the structural unit. However, the density, taken with X-ray evidence, suggests very strongly that there are 2. The other biologically important feature is the manner in which the 2 chains are held together. This is done by hydrogen bonds between the bases. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from another. The important point is that only certain pairs of bases will fit into the structure. One member of a pair must be a purine and the other must be a pyrimidine in order to bridge between 2 chains. If a pair consisted of 2 purines, for example, there would not be room for it. We believe that the bases will be present almost entirely in their most probable forms. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine and guanine with cytosine. Adenine, for example, can occur on either chain, but when it does, its partner on the other side must always be thymine. The phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of bases can fit into the structure. It follows that in a long molecule, many different permutations are possible, and therefore it seems likely that the precise sequences of bases is the code which carries the genetic information. If the actual order of the bases on one pair of the chains were given, one could write down the exact order of the bases on the other one, because of this specific pairing. Thus, one chain is, as it were, the complement of another, and it is this feature which suggests how the deoxyribonucleic acid molecule might duplicate itself. After reading the passage, we can see immediately after it gives us a table. This table shows for various organisms the percentage of each of the 4 types of nitrogenous bases in that organism's DNA. Now, looking very close to the table, a quick glance, we can see that there's a pattern that pops up. It's that, if we remember the passage, it's saying that adenine and thymine, adenine will always appear in thymine, and guanine will always appear in cytosine. If you look at the table, you can see that, for example, in sea urchins, 32.8% of all the bases adenine, 32.1% of all the bases thymine, 17.7% of all the bases guanine, and cytosine is 7.3. You can see that these 2 closely match, and that applies for all the others. Obviously, the author included this in order to demonstrate how adenine can occur in either chain, but its partner will always be thymine, and how these are the only bases. So, after reading through the passage, we should go to the questions. Question 22. The author uses the word backbone in lines 3 and 39 to indicate that only very long chains of DNA can be taken from an organism with a spinal column. The main structure of a chain in DNA molecule is composed of repeating units. A chain in a DNA molecule consists entirely of phosphate groups or of sugars. Or D, nitrogenous bases form the main structural unit of DNA. So, let's go to lines 3 and 39. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. We can see here in line 3, the word backbone is used similar to like structure or support. the structure of which consists of a regular alternation. We know this because it tells us that the chain and the backbone of the chain, or in other words, like the actual, like the most important structural part of the chain, is sugar and phosphate groups. Now let's go to 39. The phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of the bases can fit into the structure. Or in other words, the backbone, which is made of phosphate sugars, in this sentence is not referred to like an actual backbone, or saying like, in a way saying like, do not, like, in the way, if you like say, do not have any backbone. It's not saying in like no courage way, but it's saying in like, it's saying backbone as in structural support. So we go back to 22, we can see that the only answer that makes sense here would be B. The main structure of a chain in a DNA molecule is composed of repeating units. In other words, it's saying that each, the backbone is consistently repeating itself. Maybe not in the same order, but always like the same materials. It's not long chains of DNA that can only be taken from a spinal column. We've already established it's not an actual, like, a skeletal backbone. Nor is it a chain in a DNA molecule consisting entirely of phosphate groups or of sugars, as the chain would be the entire thing, not just the middle part of the backbone. Nor would it be nitrogenous bases. The word backbone doesn't mean any, does not hint toward nitrogenous bases forming a main structural unit. The word backbone, they use the word backbone to indicate that it's like repeating, it's made of repeating units. So, our answer for that question would be, in fact, B. So, let's go to question 23. A student claims that nitrogenous bases pair randomly with one another. Which of the following statements in the passage contradicts the student's claim? So if you remember, we read a part in the passage where it states that adenine can only bond with thymine, I'm pretty sure, and guanine can only bind with cytosine. So go back up, and we find that exact passage. It was down here. So if we go back down, we can see, we can also go to each line separately by itself and find it like that. For example, lines 5 to 6. To each sugar is attached a nitrogenous base, which can be of 4 different types. This does not support the claim at all that they, this in fact supports the, can be evidence that this does bond randomly, but not that they don't bond randomly. So we don't want A. 9 through 10. So far, as known, the sequence of bases along the chain is irregular. Again, this does not prove that they have a, this does not prove that they can only bond with one another. In fact, it even shows more that the actual like combinations are, this says that the actual combinations are random and doesn't support the claim at all. 23 to 25. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from another. Again, this doesn't support the fact that they don't pair randomly. So 27 to 29. One member of a pair must be a pairing and the other a pyrimidine in order to bridge between the two chains. This shows that they don't pair randomly. Pairing must be with pyrimidine and vice versa. So our answer to question 23 has to be D, as it's the only one that gives any evidence to contradict the claim. Now, let's go to question 24. In the second paragraph, lines 12 to 19, what do the authors claim to be a feature of biological interest? So, if we go to 12 to 19, second paragraph, the first feature of a structure which is of biological interest is that consists of not of one chain, but of two. Immediately, we can already see what is of biological interest. DNA is not one chain, but two chains. So we go back down to question 24. The answer is D, is that DNA consists of two chains and not one. So let's go to question 25. The author's main purpose of including the information about X-ray evidence and density is to establish that DNA is the molecule that carries genetic information, present an alternate hypothesis about the composition of a nucleotide, provide support for the author's claim about the number of chains in the molecule of DNA, or confirm the relationship between the density of DNA and the known chemical formula of DNA. So, first, we have to find where the information on X-ray evidence and density is. That is over here. However, the density taken with X-ray evidence suggests very strongly that there are two. We can see here the author includes information about X-ray in order to support his claim that there are in fact two claims and not one in the structural unit, like the chemical formula would suggest. So, the author includes the X-ray evidence and density in order to provide support for the author's claim about the number of chains in a molecule of DNA. Alright, question 26. Based on the passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it, lines 29-30, implies that a pair of purines would be larger than the space between a sugar and a phosphate group, of purines would be larger than a pair consisting of a purine and a pyrimidine, pyrimidines would be larger than a pair of purines, and consisting of a purine and a pyrimidine would be larger than a pair of pyrimidines. So if we go back to the statement, 29-30, one member of a pair must be a purine and the other a pyrimidine in order to bridge between the two chains. If a pair consisted of two purines, for example, there would not be room for it. So it's saying that one has to be purine and one has to be pyrimidine in order to bridge between the two chains, in order for the two chains to connect. If there were two purines, there wouldn't be room to connect. So you go back down. First of all, we have to find out which ones don't make sense. For question 26, if you look at the first one, that implies that a pair of purines would be larger than the space between the sugar and a phosphate group. This does make sense. Because it's saying there wouldn't be room enough for the two chains to be able to accurately bond. Because remember back in the passage, it's saying you have the two bases. Sorry, you have a purine and pyrimidine, and between them is a hydrogen bond. And saying if it consists of two purines, there would not be room for it. It's not saying, it's not necessarily saying that it would be larger than the space between a sugar and phosphate group, but rather saying there wouldn't be room for the actual bridging between the two to occur. So A is an okay choice, but it might not be the best choice. So let's move on. B. Of purines would be larger than the pair consisting of purine and pyrimidine. This does make sense, as the author states before that in order to bridge, it has to be this, and if it was of two purines, there wouldn't be room. So B does make sense according to what we said before. Implies the pair of pyrimidines would be larger than the pair of purines. This doesn't make as much sense because it says if there were purines, there wouldn't be room. In fact, if it was talking about pyrimidines, they would probably say that the pyrimidines, there's too much space in between them. And finally, the last one. A pair considered purine and pyrimidine would be larger than a pair of pyrimidines. Again, this is, nothing in this supports anything about pyrimidines or purine and pyrimidines, so it can't be D either. So the most likely answer choice here would have to be B. Alright, thank you guys for listening, and I hope this really helped you all. And please like the video and subscribe if you really liked it and to help support me, and see you guys next time.